Greetings, friends. Randall Nagy here. Welcome out to DatMan 2. As we saw in the previous video, we were able to do a lot when converting between the Python pickle format and the Python JSON format, simply by virtue of the fact they had the exact same members to use. Certainly from a module point of view, we saw that we had .load and .loads and .dump and .dumps. And this little use case diagram says we're going to have a load operation, and then rather than having the .s's, of course, we just note, since use cases are typically devoid of implementation detail, that we could either load from a string or from a file. And that pattern was wonderful simply because the person who implemented the JSON module understood the legacy and designed the module according to what everybody would expect it to do. Now, even though we do have a public interface on the pickle and JSON module, you can imagine that just like we saw with our create, read, update, and delete capabilities, that there was a lot of supporting functions that were private and hidden beneath the scenes. Keeping in mind that we can have as many different supporting functions as we want, and that the only thing that is important is the public interface, which we have. Without further ado, I would like to introduce you to yet another pattern that I find very handy whenever I'm creating software. As you saw the previous diagrams, supporting routines that we had from other classes, in this case our CRUD classes, are going to come together to help us to support what I call the S3D2 operation. What are the three S's? The first one, of course, rather than having a create or an update record, we're going to simply have the ability to sync a record. As you may discover as you use the CRUD pattern, it can be really frustrating to keep track of looking up things and seeing if they exist and whether you have to do a create or an update. So we're going to encapsulate the create and update operations using sync record, which will return the record as it has been persisted. For example, if there's a primary key ID or something else added to the record when it's saved, we're going to get that single record back from the sync operation. Unlike sync, however, whenever we're searching records, of course, we have the ability to find more than one record, but much like sync record, because we can yield one record at a time and use a filtering operation in the modern data processing world, we could use search records to iterate through or yield, in the case of Python, an individual record up until we have iterated through everything that our search function has had approved by our filtering lambda or function. Finally, we do have the idea of deleting a record. And the idea of deleting a record comes down, in my experience, to two broad operations. One, I simply want to remove the record, and I will provide a filtering mechanism, once again, either through lambda or by a function, to remove a record. Let me know what's going on there. Or I'm going to destroy a record, in which case I'm simply going to delete it from the database, and I don't really want to save anything or remove the data from the database to save, for example, as we'll show very shortly, into a backup file. The third S in S3D2 operation has to do with sourcing a record. In this particular paradigm, sourcing simply means to give me the dictionary along with the optional types that might be assigned to each one of the keys of the dictionaries and return it back to me whenever I have to create a new record or simply want to understand what fields are associated with my S3D2 operation. Available up on our GitHub account, you'll see a reference implementation using the S3D2 design pattern, and as we saw on our use case diagram, we do indeed have our classic functions included with a new feature thrown in which will allow us to put our JSON files, wherever our data files are located, into a home folder to keep the clutter away from our main Py file. Everything else is pretty much as you'd expect, complete with our create file name and base name. This time, while they could have been static methods, we kept them as dynamic just to keep the notation clear and easy to review. And we see we have our create, update, exist, base name, read, delete, etc. all supported in such a way that we can use our new design pattern to free us from the mundane chores, for example, of seeing whether something exists and updating it if it does, or creating it if it does not, as well as having many different versions of search. The only thing that really has changed a bit was the ability to have a delete too, in addition to our delete, which will allow us to save our results into an external file name. So as we discovered, the sync simply allows ourselves to reuse the create function, and we're going to say go ahead and overwrite the file if it already exists. It's a very easy thing to do, and if we have a problem, create will return null, and of course we'll have our exception. I'm not going to go through this code, and its sake of brevity, I'll just simply allow you to go run our test case and examine the code as you feel inspired and as your time may permit. The next one, of course, is search, and as it encapsulates our read as well as our list capabilities, we're simply going to go ahead and reuse our query results so as to find information that would allow us to yield a record based upon the matching of our function. In this case, as we saw in our very first lesson in this series, we understand that a function definition is different than when we choose to execute the function. The only difference here, of course, is to provide a record to our function. So whatever we provide, as we'll see in the test case, does indeed have to accept a pattern, which, if you're familiar with advanced Python and lambdas, we should be familiar with. Otherwise, please defer to my Python 2100 and 3000 activities on Udemy. Next, of course, and a bit of a surprise, was, as I've mentioned, the ability to delete files. And more importantly, when we delete a file, we're going to yield the record back so that we can do our remove operation. And while our file may disappear, the data will be preserved, which will allow us to do what's next in the delete to capability. As you can expect, we're going to put together a JSON file, having to manually add an array or a Python list to our file definition, separating each and every one of our records with a comma, keeping in mind this record is nothing more or less than a simple Python dictionary, so as to allow ourselves to save our information into a backup file. Easy enough to understand, but what I'd like to call your attention to at this point is the idea that with Visual Studio only, we have, ironically, the idea of having regions, and those regions, in this case, have always used a pound sign, in this case, pound region, beginner region, and pound end region with no spaces between the pound and no spaces in the region, to allow ourselves to do some really cool tagging and bagging and compressing of our code, which fact I lamented previously, but which technique I wanted to share with you now. Here we have our region. We're going to have our first test case, data location and data verification. The next test cases, of course, are moved down through the create, read, update, and delete paradigm using our new S3D2 capabilities. So once again, rather than going through all this code in the upfront and personal video lesson, I'll go ahead and leave it to you to review this code if and as you feel desired, have the time, or would like to take a look at a new and modern way to do some very old things using the ability to yield records rather than collect them using modern software development, data management techniques. Thanks for watching, and as I'm fond of saying, I am indeed looking forward to seeing you in the professional software development, data management, and software design and documentation worlds.